all of your exam twos. So your grades should be showing up in the grade book. If for some reason it's not, let me know. For those of you that are seated in class, I sent you each an individual email with the feedback for the questions that you missed. And if there was a comment that would kind of explain why I took off points, I put that there as well. And the key has been posted in the assignment section on Blackboard. So if you look at that key and then look at the email feedback that I sent you and you have any questions, please feel free to email me and I'll answer those for you. Does anybody have any questions about that?
I'm doing it right now. I'm putting staples back in them.
All right. So if anybody has any questions about the exam, then I'm going to go ahead and start today's lecture.
Oh, you Keysville people, I'm going to try to get Jessica or somebody to bring you your tests maybe in the next few minutes thinking about it.
I'm going to go to the office and get theirs, so I'll be back momentarily. Get out.
And I'm not, just for the sake of time, because we did miss 2 class periods, I'm not going to go over the exam in class unless somebody has a specific question. So just make sure that you look through that exam key on your own time. All right.
Sir?
Okay. Can everybody see the PowerPoint slides?
Yep.
Yes, we can.
Here we go.
Yeah.
For some reason, it looks like you're, there we go. Okay, it was one behind my screen. Okay, so just a quick review of the quality enhancement plan that I kind of mentioned earlier. I'm sure you've probably heard this in your other classes as well, but here it is again. So you need to know this because people on campus, and it's to help with the reaccreditation of the college. So just to go over this again, QEP stands for Quality Enhancement Plan. And this year, they have decided on a commitment to literacy and reading comprehension. So that's the goal. And so the title is this: I read, I lead, I succeed. So you need to know some key things about this because you may get asked if you're on campus from October 30th to, I believe, November 2nd or November 4th.
Yeah.
Tom can correct the states.
Yes.
Okay. Next. Okay. And then I also sent out an announcement with a link to a survey that they would like you all to take. So the more students that take the survey in each class, the more it looks like I actually told you about it. So please take that survey so that they know that I did in fact tell you about this. And Tom also posted an announcement with a fact sheet about the quality enhancement plan that has a little bit more information slide. So go over that and just take the quick survey. If you have time, I would really appreciate it. So that you're familiar with the quality enhancement plan.
I did do it. It's really simple. It's very easy.
Awesome. Thank you. Okay, so today we're going to talk about my favorite topic, which is animal nutrition. Just a little side note, I actually hated nutrition when I was an undergrad, and then I ended up in grad school and loved it. So I understand if you don't love it at first, but you may come to love it with time. So, nutrition is extremely important because when you're raising an animal, nutrition, the feed is typically between 60 and 70% of the cost of that animal. So you really, really want to understand the nutrition and how you can optimize it so that you're not throwing money away, because that's really vital for production. So that's what we're going to talk about today, is the different aspects of nutrition. So basically all animals require nutrients for life. That's a given. Probably already knew that much. So nutrient requirements may vary by species, which I've mentioned before in the other lectures about the individual species. So all animals require the following nutrients: energy, protein, minerals, vitamins, and water. So those are the main 5 classes of nutrients that they require. So energy has several different sources. It can come from different feed ingredients, which we'll talk about a little bit more specifically towards the end. So energy comes from carbohydrates, which are basically complex polymers, so kind of long chains of similar units, like starch and cellulose. So starch would be more of a storage form that can be broken down, and then cellulose is very hard to break down. Mammals can't break it down, but microbes can. So disaccharides are also carbohydrates, and that's an example would be lactose in milk. And then monosaccharides are glucose, galactose, sucrose. So those are kind of one sugar molecule, and then disaccharides would be two. But I'm going to go into that in a little more detail a little bit later. So this is just to kind of give you an overview to energy. So you can also get energy in the diet from fats, which would be triglycerides, di and monoglycerides, and volatile fatty acids, which is a term that I know you've all seen before. And so the three main important volatile fatty acids that you need to remember are acetic, propionic, and butyric acid. And those will definitely come up if you ever stay in animal science. I get asked about those quite often. And so those are especially important in ruminants because remember the VFAs are produced by the microbes. And so the ruminants have that large rumen where fermentation is happening even before the small intestine. So it's extremely important. And then protein in some cases can be used for energy. It's not a primary source of energy, but if an animal is really malnourished, it may start to break down protein and muscle. And that's mainly also in carnivores. So carnivores that are strict meat eater, they'll pretty much only eat it. So protein will be used for energy in that case. So proteins are just polymers of different amino acid residues. So before I like throwing this term polymer at you, I want you to understand what that means. So polymer is basically just a substance with a structure that consists of a large number of similar units bonded together. So it's basically just a long chain of similar units that are bound together to form a larger molecule. So non-protein nitrogen can also be important for protein, and urea is a good example of that. And that can actually substitute as a protein in ruminant feed. So the rumen microorganisms, which we talk about a lot because they're really important in ruminants, can actually synthesize protein from the non-protein nitrogen. So you don't have to feed protein directly. And non-protein nitrogen can then ultimately be digested by ruminants because of the microbes that are present. So again, we're going to talk about each of these in detail, but vitamins and minerals are also very essential in animal nutrition as well as human nutrition. So after taking my vitamin and mineral classes, I became a believer in vitamin and mineral supplements. So you can have a deficiency or toxicity if nutrient requirements are not met or are in excess. So it's really important that when you're formulating feed for an animal, you make sure that you have the right levels, because if you go too low or too high, you can end up killing some animals. So vitamins and minerals are extremely important. So there are two types of vitamins. You have your water-soluble vitamins and fat-soluble. So water-soluble basically just means that they are easily absorbed in the body. And so any excess will just be excreted. And those are your B vitamins. So like B12, B6, these might be things you've heard of before. Those are going to be very easily absorbed. The fat-soluble vitamins, however, have to kind of be, it's called emulsified, but basically bile acids that are stored in the gallbladder are needed for absorption of the fat-soluble vitamins. So basically the vitamins, when they're in the system, they have to be kind of coated with these bile acids because those bile acids can then be absorbed into the cell. So the fat-soluble vitamins can't be directly absorbed into the body. So that's a big difference there. And so your fat-soluble vitamins are vitamins A, D, E, and K. So water is also a very, very important nutrient. It's the main constituent of fluids of most living organisms. And water is just H2O. It's two hydrogens bound to an oxygen. So just to kind of refresh your memory if you haven't had biology in a while, I'm not going to ask you to draw that or anything, but sometimes I tend to call water H2O, so I just wanted you to be familiar with that. So some of these, again, this slide should pretty much be review if you've been paying attention for the rest of the semester. So animals can be categorized by what they eat. So herbivores are species that eat plants, including the fiber. And then omnivorous means that the species consumes plants. So that would be like grain, and then they also consume animal protein. And then carnivores, which would be fully or almost exclusively species that consume animals and meat. So those are the distinct classifications there. And I can already tell you that these will definitely be on exam 3. I'll just tell you that right off the bat, because these are extremely important that you understand the different classifications and which animals fall into each classification. So carbohydrates, like we said, provide energy. So carbohydrates are made up of carbon, hydrogen, and oxygen. And so sometimes you'll see carbohydrates abbreviated as CHO. So even in my PowerPoint, if you see CHO, that means carbohydrates. So carbohydrates include your starch, simple sugars, hemicellulose, cellulose, protein, and lignin and protein. So basically, those are all just different types of carbohydrate molecules. So carbohydrates can be produced by photosynthesis in plants, and it's essential. Carbohydrates are very essential. So glucose is the most important sugar for animals. So glucose comes from carbohydrates. So it's extremely important because glucose will later be used to make ATP that we talked about in the last lecture, which is the energy form of the body. And the body can't carry out any biological processes if it doesn't have ATP. So that's why glucose is extremely important. And starch is a principal storage form of energy in plant seeds. And so therefore it's a major part of grains like corn. Corn has a lot of starch. And so that starch can be broken down into glucose eventually. So to kind of familiarize you with how carbohydrates are classified, so it's a pretty easy system, and it's similar to how some other nutrients are classified. So monosaccharides, well, pretty much saccharide would mean like sugar, kind of. So if you think about that term, it basically is saccharide is going to mean a carbohydrate. Mono means one. You can kind of figure that out. And then di means two simple sugars. So simple sugar plus another simple sugar, di, two. And then poly, which means many, like we've talked about polyestrous, many estrous cycles. Polysaccharides just means, again, a chain or a polymer of sugar, of simple sugars. So many saccharides, basically. So that's a pretty easy system to think about and to get down, but just some terminology for you. And so then I talked a little bit about starch versus cellulose. So starch contains a chain of glucose molecules, and they are linked by alpha linkages. So that's just basically where the position of the bond is between the molecules. And so cellulose is also a chain of glucose molecules, but the difference is that it's linked by beta linkages. So the type of linkage is different between the glucose molecules of starch and cellulose. And this is important because animals can break down the bonds in starch, but they cannot break down the beta linkages in cellulose. So that's what the difference is there. So starch can be broken down by amylase, which some of you might remember that we talked about earlier, I think in the first section. So you have amylase that will start the digestion of starch. However, cellulose cannot be broken down by animals. It can only be broken down by microbes. So you have your microbes in the rumen and ruminant animals, and then you have your microbes in the hindgut of like horses, and then you also have microbes in the colon of your non-ruminant. But so obviously cellulose would kind of be more broken down in the ruminant animal, obviously. Any questions on that? I know it's kind of a lot of heavy information, so I'm trying to make it as easy to understand as possible. So if you have questions, stop. Is everybody with me so far? Okay. So again, just to kind of further show you visually how carbohydrates are structured so that you can kind of understand it if you're more of a visual person and like the picture. So this would be your glucose. I don't know if you can see my cursor. At the top, you have your glucose sugar, which is just a simple sugar. So that would be your monosaccharide. And then you have a disaccharide, which would be sucrose. And then you have your starch molecule, which is a polysaccharide, so long chains of the simple sugars. And so then on the right, you have just some of the three main monosaccharides are glucose, fructose, and galactose. And then you have your disaccharides, which are basically just different combinations of those molecules. So you can see maltose is 2-glucose, sucrose is glucose and fructose, and lactose is a glucose and a galactose. So pretty much everything just builds off of each other to get your larger molecules. So moving on to lipids. So lipids would be fats and oils. And so lipid in animal feed is predominantly in the form of triglycerides, which we talked about a little bit in the last lecture. I showed you that picture of the triglyceride with the 3 fatty acids attached to the glycerol molecule. So triglyceride, 3, so you can kind of see where we're going. So it's just 3 fatty acids plus a glycerol molecule, and that's your triglyceride. And so we also in the last class talked about phospholipids, which go to make up your cell membranes. So they're an important category of lipids because your cell membranes are extremely important, and without the cell membrane, you basically pretty much don't have a cell in animals. So those are really important. Other types of lipids, you have lipoproteins, which are just, like you might assume, a lipid bound to a protein, clever name there. And basically those just transport lipids. So fats and oils are predominantly triglycerides. And the difference between the two is that fats are solid at room temperature and oils are liquid. So if you think about, like, if you have a piece of meat that has fat on it, and you take that out of the refrigerator, that's going to be solid, that fat, right? But then you have vegetable oil in your cabinet, or canola oil, or whatever you use, that's going to be liquid. So that's just kind of a good way to think about that and which one is solid and which one is not. Pretty easy. The oils come from plants, and fats mainly come from animals, or they can be a result of hydrogenation of plant oils, which is basically just a modification of the plant oils chemically that can make them solid. So lipid terminology, like we just discussed, the carbohydrate terminology is pretty similar. So you have your mono, again, 1, di, and triglycerides. So like with carbohydrates, the term is saccharides, and then you have essentially the number term in front of that. For lipids, it's glycerides because they have that glycerol molecule that they're bound to. So you have a monoglyceride, which is just a glycerol and 1 fatty acid, then a diglyceride, which is 2 fatty acids. Triglyceride is 3 fatty acids. So this picture that you can see on this slide just kind of shows you what this looks like. So which type would this picture be? Is it a mono, a di, or a tri?
Try.
Yeah, good. So it's super easy. It's just 1, 2, or 3, basically. So lipids are made up of fatty acids. So like on this slide where, y'all are definitely a little bit late. So on this slide where you see these long fatty acids right here, we're going to be looking at that structure specifically on this next slide. So fatty acids are what make up the di and triglycerides, monoglycerides, make up lipids. So fatty acids are just a hydrocarbon chain that ranges from less than 10 carbons to more than 20 carbons. And so it can be that long with a carboxylic acid at the end and only at one end. So if in this picture, you see your long hydrocarbon chain, and so hydrocarbon just means hydrogen and carbon, hydrocarbon chain. And then at the end, you have your carboxylic acid group. So that's just how you distinguish fatty acids. So those are kind of the main features. And I'm not going to ask you to like draw the structure or anything like that. This is more just to kind of help you picture it. So there are two different types of fatty acids that you need to understand. So you have saturated fatty acids, which have no double bond, and they are solid at room temperature. And the way that I keep that straight is that saturated starts with an S and solid starts with an S. So it may sound kind of corny, but those are the little ways that I remember these. And I still, to this day, when I think saturated S, solid. Okay. So I just share that with you to maybe help you remember it. So an example would be animal fat, like we already talked about. Fats are solid at room temperature. And then unsaturated fatty acids just mean that they have a double bond in that hydrocarbon chain that we just looked at. And so that double bond will actually cause them to be liquid at room temperature. So that would be your plant oils, because we talked about oils are liquid at room temperature. So saturated, S, solid, and then unsaturated is just the other one, and that's liquid, is how I keep that straight. And so then just to see the difference in those structures, so you see your saturated fatty acid looks like the picture that I just showed you on the previous slide. And the unsaturated fatty acid is the exact same thing, but you just have a double bond there. So you have like one less hydrogen, and that forms a double bond, and that's going to change its properties. Any questions on that? Okay. So why are lipids and fats and oils used in the diet? So the addition of fats to animal feeds can increase the energy level in the diet. So this is really important if you have animals that have a very high energy requirement, like if they're lactating or if they are in gestation. You need to figure out a way to add some more energy to the diet. You can add fats. So the presence of fat in the diet also facilitates the absorption of those fat-soluble vitamins that I told you about. So when fats are absorbed, they also need those bile acids that we discussed. So when you have fats in the diet, those fat-soluble vitamins can kind of be absorbed with that fat. So it's really important to have that in there. Fats can also be added to improve flavor, texture, and palatability of feed. So just like on meat, if you have more kind of intramuscular fat, more marbling, it's going to taste better. If you have fat in the feed of animal feed, it's going to probably taste better for them too. So it's a good way to kind of get them to eat. So when people do feed analyses, they use ether, which is just a chemical to extract the fat, and therefore fats are called ether extracts if you're ever looking at a feed analysis feed. So obviously for the purpose of this class, we're going to call them fats. But if you do ever have a farm and you get back some sort of feed analysis and you're looking for fat, it's going to be listed as ether extract. So just kind of a little thing for you to know. So you have your fatty acids, and then you have essential fatty acids. So essential, like you might guess, means that they have to be in the diet. Essential cannot be synthesized by the animal. So that's really important to understand what essential means, because you have a lot of different nutrients that are essential. You have like essential amino acids, and you have essential fatty acids. So essential just means animal can't synthesize it, and if they can't synthesize it, you have to provide it in the diet. And so they must be supplemented in the diet of non-ruminants, especially, which would be like your pigs and chickens. So the two major groups, and at least one of these should already look familiar to you, are omega-3 fatty acids, which you can get from where? Fish, right, exactly. And then your omega-6 fatty acids. So the only difference between those two is the position of the double bond in that molecule. And so those are really important essential fatty acids. They're used to make other compounds in the body that are really important, which we won't go into that for the sake of this class, but just know that they're essential and that you do them. And animals need them. So proteins are a chain, or again, polymer, which just pretty much means chain, of amino acids. So proteins can vary in shape, how soluble they are, so how easily they're absorbed, the chemical composition, and their physical properties. So proteins are really important because they have a lot of biological functions. So they can be structural. They are what goes into your muscle. Proteins are in your skin, connective tissue. Proteins are part of enzymes, forming enzymes. hormones, receptors for those hormones, and nutrients in milk and eggs. So proteins are extremely important. They have a lot of different functions. So just like lipids are made up of fatty acids, proteins are made up of amino acids. And so since I don't want to keep writing out amino acids, sometimes they're just abbreviated as AA. So for the rest of the slide, AA means amino acids. So there are 20 amino acids that are found in animal protein. I actually just took protein metabolism 2 semesters ago, and there's actually kind of a 21st amino acid that's kind of coming onto the scene now, but it doesn't really have all the exact functions of these 20, so for now we're just going to go with 20. But just know that there is a 21st one that's kind of coming into the picture, because science is always advancing. So, we can always discover more. So basically there are 20 amino acids in animal protein, and all amino acids contain carbon, hydrogen, oxygen, like your carbohydrates. Remember CHO, carbohydrates have carbon, hydrogen, oxygen. So the difference between carbohydrates and amino acids is that amino acids contain nitrogen as well. And so the nitrogen is going to be extremely important. Some amino acids will also contain sulfur in addition to the nitrogen. And those are important for other functions. Like in methionine, the one that we talked about, that's really important for poultry. Methionine contains sulfur, and that's important for feather production and things like that. But for most of the amino acids, it's just carbon, hydrogen, oxygen, and nitrogen. So you can kind of see this picture of the structure. So each amino acid consists of an amine group, a carboxyl group, and an R group. So that R group just stands for the side chain. So that R group could be, it could be a CH3, it could be a long chain, it could be sulfur. So that R pretty much just stands for the unique side chain. And each amino acid is going to have a different R group there. So the R group just makes each amino acid unique because they have to be different from each other. But they all share the amine group and the carboxyl group and that hydrogen. And then just know that the R group is the part that's going to change and be unique to each amino acid. Does anybody have any questions on any of this so far? I know it's a lot of information at once, and it's a lot in an intro class. I remember all of this being thrown at me, and I was like, what the heck does this mean? So if you have any questions, please stop me, and I can try to further explain if you're not understanding the way that I'm explaining it now, because it is some heavy material. Everybody good? Okay. So just some more protein terminology. So again, you have your di, tri, and polypeptides. In amino acids or in protein, you also have tetrapeptides, and tetra just means 4, so it's just one more step from the others. And these, the bonds between amino acids are peptide bonds. So a peptide bond is just a chemical bond where the carboxyl group, which remember every amino acid has a carboxyl group, reacts with the amino group of another amino acid. So that's just where they link. The amino group will react with that carboxyl group, and you just start forming a chain that way. And water's released in that reaction, but that's not really important for right now. So peptides are basically, it's just a term for 2 or more amino acids that are bound together by a peptide bond. And so that would be any of these peptides fall under that category. So you have dipeptides, which would be 2. Tripeptides, which is 3. Tetrapeptides is 4. And then again, poly just means many. So poly would be a long, continuous, unbranched peptide chain. So does everyone understand the naming system for carbohydrates, lipids, and protein and how that works? Yes? Good? Okay. So for example, this picture, what would that be? Can you tell? That be a di, a tri, or a tetra? How many bonds do you have?
Di.
So, sorry, good answer. How many peptide bonds do you have?
2.
So you just have the one peptide bond there in red, So that's 2 amino acids. So that would be a dipeptide, which is kind of a little hard to tell from this structure. So protein is required in the diets of all animals, but more protein is required in the feed for younger, rapidly growing animals because protein helps synthesize muscle. It's used to synthesize muscle. So if you have an animal that's going to be growing a lot, you're going to need more protein. Protein requirements are also higher during pregnancy, and that's because you have a growing fetus. So again, growth and development is happening. You're going to need more protein. And then in lactation, because milk contains protein, so protein is going to be needed to go into that milk for the young. And then also the organs of the body are composed primarily of proteins. So proteins are extremely important. So just like we talked about the essential fatty acids, we have essential amino acids. So can somebody remind me what essential means before we move on? I want to make sure that you got it.
Doesn't essential mean like necessary?
Right. It's necessary because they can't synthesize it, so it's necessary in the feed because the animal can't make it themselves. Perfect. So you have essential fatty acids, and then you also have essential amino acids. So essential amino acids have to be in the diets of non-ruminant animals. So that would be non-ruminant, monogastric, remember those terms, so pigs and poultry, because the animal can't synthesize it, or they can synthesize it a little bit, but in rates that are too low for what the body needs. So some of them may be synthesized a little bit, but they don't fully meet the requirements. So those would also need to be provided in the diet. And then you also have what's called a limiting amino acid. And so it does what the name kind of says. It limits protein synthesis. So the limiting amino acid is an essential amino acid, so it's needed in the diet, that is present in the lowest concentration in the feed as a percentage of the requirement. So if an animal needs a certain amount of an amino acid, and that amino acid is just really, really low in corn, then that could kind of be a limiting amino acid situation because there's not a lot of it being presented to them in the diet, and they actually require a good amount of this. And that changes depending on the species. So for example, which you don't really need to know this, but just to kind of show you how this differs, lysine is a limiting amino acid in pigs because they require a good amount of it, and the ingredients in pig diets are pretty low in lysine. So methionine is actually the limiting amino acid in poultry because they require a lot of methionine for feather production. So just a little difference between species. So it's not always the same limiting amino acid. It varies based on the species. So basically that limiting amino acid limits the use of other amino acids because protein synthesis is kind of an all or nothing deal. So if you're synthesizing protein and it gets to a point where it needs an amino acid that's not there, it will stop. So that's why the limiting amino acid concept is very important because it does limit protein synthesis because protein synthesis cannot continue without that amino acid. Does that make sense? Okay. So there are also some things known as rumen bypass products. So these are basically just nutritional products that are treated in such a way so that they will not be fermented in the rumen, and that way they will be digested in the small intestine. So basically, nutritional products can be kind of coated with something that the rumen microorganisms will not digest if you want to get a nutrient directly to the small intestine of the cow or ruminant animal for it to be absorbed there. So bypass means it's going to bypass through the rumen. So it's not going to be digested in the rumen. So you have bypass protein, and then you have bypass amino acids. So if you need to meet specific requirements of a ruminant animal, you can do it that way. So a big advantage is that you can meet the nutrient requirements of cattle under different circumstances. So for example, lactation. So remember when we talked about dairy cattle, we talked about lactation is the point where you can't meet their energy requirements and their nutritional requirements because they're using so much for milk production. So this lumen bypass protein or any products would be really important in dairy cattle, for example. So it's basically if you just want to get more nutrients directly to the small intestine of a ruminant animal, this is a way to do it. So proteins, like I said earlier, in some cases can be an energy source. Typically, it's only in cases of like malnutrition. So the amino acids can be converted to glucose and fat and used as an energy source. So an example of when this might happen would be when more amino acids are absorbed than you actually need for protein synthesis. So you've got a lot of extra protein hanging around. And so what can you do with it? The body might store that as, it might store it as fat or convert it to glucose to be used. So if you kind of think about, you know, people eating, you know, first you're going to start putting down muscle, and then excess nutrients that you have, like if you have too many McDonald's cheeseburgers or something like my father, you will start to put down fat. So if you have excess protein, that might be converted to fat. So also another way that proteins might be used for energy is when an animal is nutritionally deprived. So if you have an animal that hasn't eaten in a couple of days and it hasn't gotten those carbohydrates and fats in its diet, it actually will start to break down muscle. Muscle will start to be broken down in the body, and that muscle can be used for energy. So those are two situations there where protein might be used for energy. And also, like I said, in animals that are carnivores, because they're pretty much just eating protein most of the time. So that protein is going to be an energy source for them. But those are really the only cases right there. So you also have some unavailable protein situations that can happen. So if a feed is not stored properly, the protein can actually be degraded, so broken down, or denatured, so it'll lose its structure and its function. And then it's not digestible and it's no longer available to the animal. So how we store feed is just as important as what's in the feed, because that can impact the actual nutrients that are going to be there once it's fed to the animal. So you can have, and animals can have, protein deficiencies. So like I said, if you don't have all of the amino acids there, protein synthesis will be halted. And protein synthesis is not just for muscle. It's, remember, hormones, cell membranes, receptors, lots of different things that go on in the body need protein. So if you have a deficiency in protein, it can be a real problem. So it can cause reduced or halted growth, reduced fertility in adults, and then that will cause the breakdown of muscle and other proteins in the body to meet the bodily need. So you always want to make sure that you or any animals that you have are getting enough protein. So different sources of amino acids would be the proteins found in feed ingredients. So some of the major protein sources in animal feed are soybean meal, which we've kind of mentioned before, fish meal, animal plasma, and poultry meal are kind of the top ones that are mainly used. And so, for example, for pigs, for baby pigs, we'll actually include pretty much all of those ingredients that are available in different amounts, because they all have very, very good digestible protein. So vitamins are chemicals that are required in small quantities in feed or food for health. So remember, in I think it was the last lecture where we talked about feed is when it's going to be fed to an animal, food is when it's fed to people. So just that's why I have feed and food there. So there are 16 vitamins that are essential for animal nutrition, meaning they have to be provided in the diet. The rumen microorganisms, which are some really, really helpful little bugs, can synthesize some vitamins. So they actually can do quite a lot. So now I think you might start to see the importance of the rumen and ruminant animals, and why I wanted you to understand what goes on there, because they can synthesize protein and they can synthesize vitamins as well. So some animals can synthesize vitamin D in the skin when exposed to the sunlight, and that's actually true for humans too. So if you spend a lot of time indoors and you're never really out in the sun, you might be slightly vitamin D deficient. So just go stand outside for 30 minutes a day. So that I thought was kind of cool, that vitamin D can actually be synthesized in your skin. Because I actually didn't know that until I took a vitamin class. So I thought that was neat. So again, to kind of review, like I said earlier, you have your water-soluble vitamins, which means that they're easily absorbed in the body. They are poorly stored in the body. So just because they're easily absorbed doesn't mean that they're going to be easily stored. So when they're easily absorbed, they're poorly stored in the body because excess will just be excreted. And so again, those are going to be your B vitamins. So then you have your fat-soluble vitamins, which again require bile acids for absorption. So if you have fat in the diet, that will help the absorption of those. And these fat-soluble vitamins can be stored in the body because they're not as easily absorbed, but they can be stored for later use if needed. So those are your vitamins A, D, E, and K, just to refresh your memory. So vitamin deficiencies are very rare in livestock that are fed complete feeds. And so a complete feed would just be formulated to meet all of their nutritional needs. However, if you don't have a complete feed, you may need to supplement some vitamins. So commercial feeds typically include vitamins. So they will have A, D, and E for ruminants. And that's because the rumen microbes can actually synthesize a lot of the B vitamins, so you don't need that in the diet. And then for monogastrics, you're going to have commercial feeds that have vitamins A, D, E, K, and then riboflavin, a bunch of other vitamins. B12 is going to be in there, and then choline chloride as well for pigs and poultry. So pretty much you need a lot more vitamin supplementation in monogastrics than you do in ruminants because the ruminants have the microbes in the rumen. That makes sense? Good. So just like vitamins, minerals are also really, really important. And so they're kind of broken into these two different categories. So macro minerals, macro just means a lot, big. So large amounts are needed. And so when I say large amounts, I just mean large, like kind of in relation to other minerals, not large amounts like half the diet or anything like that. Just large amounts compared to some of the other minerals. So it's still in a complete diet, minerals and vitamins are still going to be in small amounts overall. Does that kind of make sense? I feel like I said that kind of confusingly. So your macro minerals are just the minerals that are needed in larger amounts compared to some of the other ones. So that would be like calcium, which everybody has heard of, I'm sure, in milk. It's really important, and it can be found in other things too, but milk's kind of the one you think of. Sodium, potassium, and chloride. And so those are really, really important. And then your micro minerals, which are also called trace minerals. So sometimes you may see the term micro minerals, you may see the term trace minerals. So I have both of those there just so that you're aware that those do mean the same thing. So that just means micro means small amounts are needed compared to the other micro minerals. So micro, if you think about it, versus macro means small. And then trace, they're just needed in trace amounts. So just a very little amount. So that would be like your iron, copper, zinc, manganese, selenium, and iodine. So I know we've like kind of talked about a few of those a little bit, like copper can be a problem with sheep. And so your micro minerals kind of need to be supplemented if there's like a deficiency in the soil in that area for ruminants or something like that. Some soils are low in selenium, so you might need to supplement things like that. So that's kind of where those come into play. And like, for example, baby pigs are extremely iron deficient, so they're given an iron shot. So that's where micro minerals kind of come in if they're not being gotten from other sources. So how do you know what the How do you know what the nutrient requirements are of a species? How do you find that information? So the National Research Council, or the NRC, actually publishes nutrient requirements for livestock species and horses as well. So each species pretty much has their own book. So when I want to formulate for pigs, I go to the nutrient requirements for swine. And these are based on industry studies. So studies that have actually been conducted at commercial farms, and those studies have been done to determine how much protein a pregnant cow needs. Okay, so they have different nutrient requirements based on the different phases. So most people will typically use it as a guideline, and they will typically exceed the recommendations, so just by a little bit, to ensure that the diet is meeting requirements. Because if you supplement exactly what they need, you may be just a little bit under, because again, this is based on kind of averages from studies that were done. So people will typically supplement just a little bit more than what they recommend. That way you know you're hitting the mark. But just a little bit more, because you don't want to waste money and you don't want to waste nutrients. So these can actually be found online. So if you have any cattle farms or hog farms or anything, and you are wondering about what you need to be feeding them, you can look up the NRC guidelines.
Do they go breed specific, or are they just cows and pigs?
They don't, to my knowledge right now, go breed specific. I know the swine one doesn't. It's pretty much just for different phases. So like, for example, for pigs, you would have requirements for boars. You would have requirements for sows for each phase of gestation. So they pretty much break it down by phase of production. And so like for pigs, once they're born, and there's like 5 or 6 different phases of requirements based on how big they are and how much they weigh. So it's not really breed specific. But the books also will contain information on feed ingredients. So like at the back, you can find like corn, soybean meal, fish meal, and like how much protein and energy is in each of those, and how the amino acids that are in each of those ingredients. So it's they're really helpful books if you're going to be doing any sort of nutrition and formulation. But unfortunately, they don't really get breed specific that I know of.
Okay. Cool.
But they come out like every couple years. So like at least once a decade. So that might be something that in the future we might see.
Yeah, I probably haven't looked at one since before you were born. That's why I thought I'd ask.
Yeah, the one I use is the 2012 is the last version, and the one before that I think was 1998. So hopefully there will be another one coming out in the next few years. So now we're going to talk a little bit about feed supplements. So in addition to what the required nutrients are, you can also add different supplements. So some of these may be prebiotics, probiotics, enzymes, or organic acids. There are a whole lot of other feed supplements that you might see, but these are kind of some of the major ones that are a little bit more common. So prebiotics are nutrients that are supplemented, that are basically just there to increase the amounts of beneficial microorganisms in the intestinal tract. So in the digestive tract of pretty much every mammal, you have microbes. Even in pigs and poultry, like I said, once you kind of get towards the colon and the cecum, you have microbes that are there. And so you can have good microbes and you can have bad microbes. And basically, prebiotics just want to increase the number of good microbes. So they're basically a food source for the microbes that would be really beneficial. So that's a prebiotic. And then probiotic is actually what my research is on for my PhD. So they're actually kind of called direct-fed microbials now. But probiotic is just a population of beneficial microorganisms that are added to the feed. So prebiotic is a source of food for the microorganisms, and the probiotic is actually feeding a microorganism. So that's the difference. So you might have heard those terms before. So like probiotics are in yogurt. Yogurt has a lot of active microorganisms that are beneficial to your health. And like I said, those are also called direct-fed microbials, which is what I'm working with. So I can tell you a whole lot of random things about them. And then you also have enzymes, which are biological catalysts that accelerate chemical reactions. So you can supplement enzymes. So we mentioned phytase. So phytase can break down that form of phosphorus, phytate, and make phosphorus more available to the animal. So phytase is kind of the classic example of one that's tried and true, and it's used a lot in the industry. So organic acids are also another feed supplement that can be used. And so they basically, they're acids, they're acidic, so they can lower the pH of the gastrointestinal tract. And this is important because that can actually inhibit pathogen growth. So pathogens like E. coli or Salmonella can't really tolerate a low pH, but some of the beneficial microbes can. So that's why organic acids kind of come into play. So phytase, like I said, is kind of one that we're going to focus on because it's had consistent results and it's used fairly often, especially in pigs and poultry. So in some feed ingredients, phosphorus, which is a mineral, is stored in an unavailable form known as phytate. And so when fed to animals, this phytate can actually form complexes, so it can bind to minerals and some amino acids. And when this happens, it can actually prevent them from being absorbed and used by the animal. So phytate can be very, very bad to have in a diet. So phytases are enzymes that are added to pig and poultry diets that can actually break down this phytate. So when that phytate is broken down by the enzyme, the phosphorus is released and the animal can use the phosphorus. So phytases are really, really important. And so because the phytases make the phosphorus more available for the animal to use, you have less phosphorus excreted into the environment because more of it's being used by the animal. So that's why phytase is kind of a really big one. Does everybody understand that? Okay. So now we're just going to talk a little bit about some toxic plants and different toxins that you might come across with different feed ingredients. So fungi produce mycotoxins, which can be found in moldy grain. So like you see this picture of some extremely moldy corn. You wouldn't want to feed that to animals, not just because it looks gross, but because it can contain mycotoxins. So mycotoxin contaminants can have negative effects on the animals consuming the grain. So it can really impact their performance and their health. So just to kind of go over a few of the different mycotoxins that are out there, some of them are a bit of a concern in other species and not so much in different species. So like, for example, horses kind of have certain mycotoxins that you need to watch for more so than ruminants. So aflatoxins are a big one, and they're the most commonly occurring mycotoxin. And so it's found in a lot of different feedstuffs, including corn, which, as I'm sure you've gotten by now, corn is a major, major energy feed and livestock feed. So anything that can be affecting corn is a big deal. So ergot is also another one. It's basically just a fungus that's found on a variety of different feed ingredients. And so it produces a mycotoxin that can actually act in the central nervous system, and it can cause kind of convulsions or seizures, hallucinations, and a prickly sensation in the hands or feet. We also have endophyte fungi, which is a mycotoxin that's produced in tall fescue grasses. So that could actually cause reproductive problems in pregnant horses and fescue toxicosis in cattle. So if you have cattle and you have any fescue pastures, you might want to be aware of this. So fumonisins is another one, and that's a common mycotoxin in corn. And ingestion of fumonisins can be fatal in horses at concentrations of more than 10 parts per million. And it can reduce the efficiency of growth in pigs. So like I said, horses can be a little bit more sensitive to some of these than other animals. So it's really important to be aware of, especially, like I said, if you have fescue or if you are feeding your horse some corn, fumonisins can be a really, really big problem. And then zearalenone is a mycotoxin that has estrogenic activity. So it kind of acts like estrogen, and it can actually cause infertility in pigs when it's in high amounts. So it can cause reproductive problems. So how do you avoid mycotoxin contamination? So grain is tested for mycotoxin concentrations to ensure that contamination is below the FDA acceptable limit. So the FDA kind of understands that you're not going to necessarily get corn that has at 0, parts mycotoxins. So they've established what are called like their safe levels that the feed ingredients cannot exceed. So they can have a little bit of mycotoxin, but there are certain levels for each mycotoxin that you can't have more of. So when producers are getting their feed, they're getting it from a feed mill most likely. So when any ingredient comes into the feed mill, it's going to be tested for mycotoxins. If it's above that level that's required by the FDA, that feed ingredient will not be used for livestock feed. So if you're getting corn directly from somewhere and it's not being checked, you may want to check it and make sure it's not super moldy and check it for mycotoxins. So one way to avoid this is the addition of clays to feed. There have kind of been the development of products using clay, just like clay like you would find in the soil, that may actually adsorb to the mycotoxins. So it's not supposed to be absorb, it's actually adsorb, which means it kind of just attaches to the mycotoxin. And when it does that, it will make them unavailable. And then some enzymes can deactivate certain mycotoxins. So there's some strategies there to kind of avoid this contamination if you have a problem with moldy feed ingredients. So there are also toxic plants that can just be found around in pastures or wherever outside. So many plants produce chemicals that are toxic to animals. So toxic compounds that they produce are called phytotoxins. And so those can be in a variety of different plants. For example, red maple leaves for horses, black cherry is bad. I'm not going to read that whole list. But so these are important to know if you have cattle or horses or sheep that are going to be outside. Make sure that you don't really have any of these toxic plants anywhere near your animals because it can cause problems. Or also if you have a dog like I do who insists on eating every poisonous looking plant that he can find when we go outside. So, so to kind of give you some more information on the different animal feed ingredients that are available. So for energy sources, you have corn, which is the most popular, which we've talked about a lot. And that's a good energy source for pigs and poultry. Other sources would be other cereal grains like sorghum, oats, barley, and wheat. You could have citrus pulp or other pulps, boiled fruits and vegetables, or outdated human food. So actually like any breads or cookies or anything from the grocery store that's going bad or past the expiration date, those can be sent to different feed mills and places like that and actually turned into feed that can be used for pigs, which I thought was kind of cool because someone actually did a study where they fed like different types of cookies to pigs and saw what happened. So that food is not being wasted, which is really good. And then protein sources are plant-derived protein, so any protein that's coming from a plant source. Animal-derived protein, so like your fish meal, your poultry meal, those are coming from animals. Bacterial and other microorganisms derive protein and specific amino acids, so that would be like in the rumen, those microorganisms are producing protein. And then synthetic amino acids can be supplemented individually. So synthetic amino acids just means amino acids that have kind of been developed on their own. So for example, I talked about in pigs, lysine is a big limiting one because it's required a lot and it's not as much in the feed. So synthetic amino acids allows you to feed individual amino acids. So when we formulate pig diets, we actually will include an ingredient that is just lysine for the pig to kind of supplement the other feed ingredients. So that's the importance of synthetic amino acids. And then non-protein nitrogen, again, for rumen microbes, they can synthesize amino acids from urea, which is a good non-protein nitrogen example. Legumes can also be incorporated. So those are plants that can fix atmospheric nitrogen to ammonia and nitrate. So these can then be, the ammonia and nitrate can then be incorporated into amino acids, proteins, and other nitrogenous compounds. So again, proteins contain nitrogen. So anytime you think of nitrogen in the feed, think of protein amino acids. And so nitrogen-fixing bacteria actually live in the root system of these plants. So they have a symbiotic relationship where they're benefited and the plant is benefited. And so basically all of this is important because the seeds of legumes can be used in animal feed. So those would be like soybeans, alfalfa, beans, clovers, and peas. Those can all be used in animal feed and they kind of fall under the category of legumes. So they can be important for amino acids and protein and things like that. For ruminant feed, there are three main types of ruminant feed that you have. So you have forage, which would be your high fiber feeds, including hay, silage, pasture, and any rangeland. And then you might supplement them with concentrates, like especially in the winter if their pasture quality is going down or their pasture is dead. So that includes grain that's ground as feed or ground and fed as a meal. You may have pellets. That could be including animal proteins like we talked about, fish meal, blood meal. And then it could be protein from rendering of other animals, protein from milk that has gone bad. So milk can actually be further processed to get like whey protein, which some of you, if you go to the gym a lot, you may take like whey protein shakes. So that comes from milk. And then salt, which contains your trace elements. So salt is basically sodium and chloride. So those are all important for ruminant feed. So now we're going to keep talking about feed ingredients, but we're going to talk about byproducts of those feed ingredients. So there are two major types of milling that can happen with feed ingredients. So you have wet milling and dry milling, which are kind of pretty self-explanatory. Wet milling involves the kernels being steeped in water. And so during the milling process, the soluble components, so the components that are absorbed in water, like the starch, will move into the steeping liquor and then concentrate it. So corn gluten feed is a byproduct of wet milling that comes from corn. And so it is good for protein and digestible fiber. So if you ever hear corn gluten feed, that's where it comes from. And then for dry milling, corn can be ground and used directly in feed. And so the corn is typically ground, especially for pigs and poultry, because the smaller particle size makes it easier to digest. So that's why it's ground up for those animals. And then a byproduct of this dry milling is distillers' grains with solubles, and that's a good protein and energy source. So just a little bit about the impact of bioenergy on animal feed. So starch resulting from milling is used as a chemical feedstock for fermentation and can be used to produce ethanol. So ethanol, some of you have probably heard about it, but it's used as a fuel in a 10% blend. And so there's a tendency to increase dry milling due to greater efficiency in ethanol production. So ethanol production has become more important in recent years, and it's likely to exceed 6 billion gallons in 2007 or 2008. So this is important because the use of corn for ethanol can actually drive the price of corn for livestock, and it can affect the use of corn for livestock because you don't want to get the crappy corn to feed to your animals. So livestock producers have to kind of compete with ethanol production to get this corn. So it has caused increased corn prices. However, it's a good source of byproducts such as DDGS. And there's been an increase in acreage planted to corn and the decrease in soybean acreage planted because corn now has another reason that it's used. So now we're just going to talk a little bit about some nutrition calculations. So this is it can be a little bit complicated at first. So I'm just going to try to explain this as best I can and then kind of show you an easy example. So basically when you're looking at feeds, you have what's called a dry matter basis and an as-fed basis. So when you're looking at nutrients in a feed, they're going to be on either one of those. So dry matter is just what you would think it would be. It's dry. It doesn't have water. And then the as-fed basis is how it's going to be presented to the animal. So exactly as it's fed. And that includes water. So that's just the difference between that terminology there. And it's just kind of important to know that there are two different ways that nutrient values can be expressed. So the percentage of a nutrient on a dry matter basis will always be higher than on an as-fed basis. So if you're looking at the amount of protein in corn and you're looking at it on a dry matter basis, it doesn't have the water in there to dilute that nutrient. So the percentage of that nutrient is going to be higher. So it's this takes a lot of just kind of thinking about this and trying to get it straight in your head. It took me a while, so don't feel bad if you're not understanding this right now. So then the amount of feed on a dry matter basis, like the total amount of feed will always be lower than the amount of feed on an as-fed basis. And that's because dry matter basis doesn't contain the water and as-fed does. So if you're talking about how much you're going to feed in terms of dry matter, it's going to be less than how many pounds you would feed an as-fed, because that as-fed is going to include the water. So just to kind of like get familiar with this slide and understand the difference between dry matter and as-fed, that dry matter is without water, as-fed does include the water, and how that kind of impacts what you're looking at when you're looking at nutrients and amount of feed. So I'm not going to make you do this. So this is mainly just for those of you that are interested. If any of you formulate your own feed or do anything like that, this is just kind of for your information if anybody wants to look at it. But this is kind of really hard to understand, and I think for an intro class, you don't really need to do these calculations. There's a simpler calculation that I'd like you to be more familiar with. So this slide is just more for your own information. So the one type of calculation that I am going to ask you to do for this class, and it's pretty easy once you get the hang of it, is the Pearson square. So the Pearson square is designed for simple ration calculations. So if you're just making a simple ration, and so there are a couple of rules for the Pearson square. So I'm just going to kind of go over these rules, and then you'll see what I mean in a second. So the numbers on the left have to be on the same basis. So the basis that we talked about, they both need to be dry matter or as fed. So for the Pearson square, you're always going to be using 2 ingredients. So you want to make sure they're at the same, expressed on the same basis. The number in the middle of the square has to be a number between the 2 numbers on the left. And you're not going to worry about negative numbers, so you only want to look at the difference. And all of this will make much more sense on the next slide. And then you're always going to subtract diagonally. And your ingredient names will go straight across. So now I'm going to explain this again with this example. So you want to formulate a feed that has roughly 25.5% protein, right? So that's going to go in the middle of the square. That's your goal. So you have 2 ingredients that you want to use for this ration. So you have barley and you have soybean meal. So those ingredients are going to go on the left of the square. So to figure out how much protein you need to know how much protein is in both of those ingredients. So CP just means crude protein. So your barley is 11% crude protein, and your soybean meal is 44% crude protein. So like I was talking about the rules, so both of those ingredients on the left, those numbers would either need to both be dry matter or both be as fed, because if one is on a different basis, it's going to completely throw you off. So let's just say that these are both on an as-fed basis for this example. So the other rule is that the number in the middle, so the number of the amount of protein that you're trying to achieve, has to be between the amount of protein found in each ingredient. So you see, like 25.5 is a number between 11 and 44. So those are the rules of using this square. You can't have it lower than the ingredients or higher. It has to be a number in between in order for the square to work, this calculation to work. Is everybody kind of with me on that so far? Yes? No? Totally lost? Okay.
You're with it?
Yeah.
Okay.
It's kind of a lot, and I'm going to go over it, a couple of times because it's hard to understand at first. So when you want to reach this ration that has 25.5% crude protein with these 2 ingredients, you need to figure out how much of each ingredient you need to use. So the way to do this with the Pearson square is that you subtract diagonally, so you find the difference between the ingredient on the left and the number in the middle. So for barley, you're going to go down diagonally. So, and like I said, disregard negative numbers. So you only want the numerical difference. So it wouldn't be like 11 minus 25.5 is negative 14.5. It's just the numerical difference. So it's going to be 14.5 would be the difference between those 2 numbers. Does everybody understand that?
Yeah.
Right, because you're not going to be like, there's no way you can feed negative percentage of something. So then for soybean meal, it's the same thing for that ingredient. You're going to find the difference and you're going to go up. So if you follow the arrows in this picture, you're going to just find that difference, and then that number is going to go up at the top. So you're going to subtract and find the difference diagonally. So once you've found those differences, you're going to bring the ingredient names straight across. So that's kind of one place that a lot of people get mixed up. And I kind of did when I first started learning it, is that you want to kind of carry that ingredient name down with the number, but that's not the case. So always subtract and find the difference diagonally, and then carry those ingredient names just directly across the square. Yep. Thank you, Tom.
Oh, you didn't see, I didn't know you saw me doing the Vanna White. Oops.
I did. I was about to say thank you, Vanna, but can they see my cursor?
Yeah.
Yes.
Okay, then I can kind of use that. I can't tell.
Can y'all see it in Keysville, her arrow?
Yeah.
Okay, good. So that will kind of help explain it. So find the difference going that way and then diagonally, and then just carry your ingredient name straight across. So when you find the differences for this example, that's going to give you 14.5 and 18.5. And then you're going to carry the barley across and the soybean meal. So is everybody good with that part?
Yeah.
Okay. So then to get your total parts, you're just going to add the 18.5 and the 14.5. So just add each ingredient, and that's going to give you your total amount of parts that you need for this formulation. That's pretty easy. So then if you want to convert these to a percentage, which will make it easier for you when you're formulating the diet, all you need to do is you're just going to take however many parts you have of ingredient 1 and divide it by the total, and then just multiply by 100 to get your percentage. So is everybody kind of familiar with how to get percentages and things like that?
Yeah.
Okay. So that's all you're doing. So you just have the portion that of the ingredient over the total, and then multiply by 100, and that gives you your percentage. So for this example, that would give you 56.06% of barley. And then that would give you 43.94 percentage of soybean meal. And so just be careful with your decimals because you want to make sure that your total ends up to be 100. So for example, if you don't, if I hadn't gone out to those 2 decimal places, I would have to round up to like 57 and then round down to 43 to kind of make sure, actually be 44 and then 56. Does that make sense? So it just kind of depends on how many decimals you want to round out to, but always make sure that your rounding is correct so that when you add up those percentages, you get to 100%. So that's a good way to check to make sure that you did the square correctly, is when you carry it out to percentages, do you get 100%? And you need to get 100%. If you didn't, then you did something wrong. So that's a good way to kind of check this calculation. So does everybody kind of understand the Pearson square
Yeah.
and how it works?
Yeah, that's good.
Okay. Because I'm gonna have you do one of these calculations in an assignment coming up probably next week that I'm gonna put together. I'm gonna try to have an assignment with some questions from the lecture before this, and then maybe some from this, and then the lectures I'm gonna do on Tuesday, because I know this is kind of challenging material, so I want to give you an assignment to kind of help you review and stay up to date on the material. But I would like for you to be able to do a Pearson square calculation. Because I'm not going to ask you to do the other kind of a little bit more, I think, complicated ones. So Pearson square, I think, is kind of an easy one for you to get down.
Yeah, once you practice this a few times, you can see that it's elegantly simple when the dust settles. And for those of you that are mathematically challenged, well, you're doing subtraction, and you're doing a quick addition here, and you do a couple of small little divisions, and that's really it. It's nothing really mathematically to freak out about for those of you that have math anxiety or something like that. It really is just adding, subtracting, and a little bit of multiplying and dividing at the end, but it's really not that bad, and it's a beautifully elegant solution.
Yeah. Once you get it, I might sound like a total nerd, and I may be alone on this, but once you actually get it, I find Pearson squares kind of fun.
I used the word elegant. I didn't use the word fun, but
yeah, elegant's probably better. It makes you sound like less of a weirdo. But I actually enjoyed Pearson square problems once I understood it.
I don't understand the first part. I understand the second part and how you transfer over from barley to parts barley and.
Now, how far back? Do you know these two numbers, the 11 and 44? You're getting those from the feed requirement manual.
Yeah.
So you're looking in the book and it says you need to be feeding 11% barley, or they need 11% barley, 44 soybean. You get those numbers, but this is
Where's that number?
no. These are the numbers that are on your feeds, the feed that you're getting.
So that's how much, like for this example, you're trying to figure out how much you need to achieve a certain protein percentage. So those are like barley has 11% protein. Soybean meal has 44% protein.
If you pick up a bag of barley, it's going to say You pick up a bag of barley, it's going to say you have 11%. Can you talk a couple seconds to get the screen back?
Yeah. So yeah, if you pick that up, so like if you're doing a problem, that will be given to you in the problem. You'll have like this ingredient is this percentage of whatever you need to calculate. So that information will be given to you. So you don't need to calculate the numbers on the left. Does that make sense?
These two are going to be on the bag. This is what you're going to look up. That's your target.
Yeah.
Where do you get that number?
This 25, that's from the manual, the recommendation.
So that would basically be like if you looked at an NRC book and it says like a cow that's lactating needs 25.5% crude protein. You would find that information from your book or whatever guidelines you're looking at to formulate your diet. Does that make sense? So again, in a problem, that would be given to you. I would give you that number.
Oh, not how do you get, this is what you're shooting for. You're aiming for 25. You have something that's 11, that's too low, something that's 44, that's too high. So that's what the subtraction is giving you. It's doing a proportional, I can't think of the words again. Yeah, you just subtract 44, take away 25 and a half, it's going to give you the 18 and a half. 25 and a half, take away 11, it's going to give you 14 and a half. So proportionally, because
Okay, I see.
yeah. So the barley is almost as far below your target as the soybean is above your target. That's why this 18 and a half isn't. Those numbers aren't that far off. So you're not quite doing a 50-50 mix, but you might be mixing something that has like almost no protein in it. So you may have like a 2 compared to a 44. So you're going to be putting, if it's doesn't have much, you got to use a whole lot of it. So these numbers are going to fluctuate. In this case, they're this is far enough below and far enough above that you're about doing 50-50.
The percentage in the middle, you're subtracting
Yes.
the ones on the right.
Yes.
And then that'll give you your.
Yes. So 25 take away 11 is 14. 25 take away 44 is 18. And then you bring the barley over. You bring the soybeans over.
I understand that part.
Yeah. Okay, and then you understand the percentage part. Okay.
Yeah, I was just confused about the first.
Good. And what I'm gonna do, since we're kind of getting a little bit close on time, actually I think according to my watch it's already 11:50. I'm gonna do an example of one of these at the beginning of next class so that we can kind of review it again. And I may honestly just, if you still don't get it, we may do an example before the next few classes, just so that everybody understands it. So be familiar with this slide and the previous slide, kind of read the rules, and we'll go over it again at the beginning of next class. Does that sound good?
Sounds
good. If we're really slick, what I can do is like connect a few minutes before class. You can just shoot one of them on the screen, do a screen share that they can be messing with while they're coming into class and talking about coffee and whatever they talk about.
Okay, yeah, that would be great.
Just, a pre-class, something to think about. If I remember next Tuesday, I'm going to be in a different classroom, so don't be surprised if I connect a couple minutes late.
Okay, no problem.
Accidents happen.
All right, well, that's all I have for today. So y'all have a good Thursday and enjoy the rest of your weekend.
So anybody have any other questions? Keysville people, keep an eye on your email, like I said, Monday and Tuesday, because I'm about 70% sure they're going to boot you. Y'all have a good weekend. Yeah, 9 o'clock here. Be at the Shoppers Fountain like 9:30. Goes yell at Keysville. See you tomorrow. Yeah.